Okay, handshake protocol. Here, handshake protocol, it is used for establishing the connection between client and the server. Now, here for sending the messages, that message comprises of what? How many fields? Three fields. First one is what? Type. It's going to be occupy 1 byte, and length. It is of how many bytes? 3 bytes. Content it is greater than or equal to 0 byte. What I said? Type it is of 1 byte, so it going to take one out of the 10 messages. So we will see, we're going to learn the SSL handshake protocol messages. We're going to learn now SSL handshake protocol messages. First one is what? First message type, that is hello request. Hello request, it going to be sent between the client and the server before connection establishment. Before the connection establishment, so between the client and the server, or between the two entities, first the two entities, it going to be send the message, that is message type is what? Hello request. First it is assigned to the value null. Second one is what? Client hello. Client hello means what? This is the message. If client wants to communicate with the server, client is going to send the hello message to the server. Client is going to send the hello message to the server. What are all the initial parameters are there in that hello message, client hello message? One is what? Version. That is regarding SSL version. For example, SSL v3 version is 3. Random, that is what? The random number, that is a nonce value. Okay, random number, that is what? Nonce value. Already we discussed the nonce value, and that is with respect to public key encryption. Then session ID. For each and every connection, there is an ID. For each and every connection, there is a session. For that session, that is nothing but what? Temporary time period. In that time period, that data is going to be sent between the client and the server. Okay, they can communicate up to that some amount of time. That is for each and every session, there is an ID, that is what? Session ID. Then cipher suite. Cipher suite is used for which encryption algorithm you're going to use, and that is either AES algorithm, DS algorithm, triple DES, or RSA, anything. Then compression method, this one is what? Optional, what I said early here. Okay, this is what, suppose if you are not using any compression method, you can directly take the plain text data. Otherwise you can take data, then you can pass the data to the compression algorithm, then data is in the what? Compressed format. Okay, these are all the parameters, that is what? Initial parameters you're going to send with respect to client hello message. And then same thing with respect to server hello message, that is what? Version, random, session ID, cipher suite, compression method. Then certificate. Now here certificate, which certificate we're going to use? That is what? X.509 certificate. That is also we discussed in previous class. Okay, certificate here we use it, that is what? X.509 certificate. Then server key exchange. Before connection establishment, server is going to send the message to the client, that is server key exchange, that is going to give the public key of the server. Okay, server, it will give public key of the server to the client. Then certificate request. Now what? Either client or the server, they going to request the certificate. Between the certificate, either server or the client, means either any entity is going to request the certificate from the authority, that is what? Public key authority. Now public key authority, it going to issue certificate to the entities based on that certificate, because signature, everything is available in the certificate, so that two entities are trusted, then they can communicate with each other. Okay, either any entity, they can ask for the request, that is what? Certificate request, to authenticate another entity. For authentication of another entity, we need certificate request message. Then server done. What are all the things are there with respect to server done? Whenever if server wants to end with respect to hello message, then it will send the message, that is what? Server done. Next, certificate verify. Any entity, it can verify the certificate using what? Public key authority, by using what? Signature. This signature is going to be given by the any public key authority. Any public key authority is going to give the signature. This is what? Certificate verification. Any entity, it going to take the it going to verify the signature, right? Then client key exchange, that is the what? Client it going to give the its public key to the server. Okay, client is going to exchange its public key to the what? Server. what are all the parameters here? Parameter with signature. Signature is given by whom? That is what? Third party, that is public key authority. Then finish after connection ending between client and the server, it's going to generate the hash value. This one hash value is going to be append to the particular message. These are all what message types with respect to what SSL handshake protocol. Okay, now this is what 10 messages. Hello request, it's going to be first, if any two entities wants to communicate, first they're going to send the hello request messages. Okay, client hello, this is the message. It's going to be sent by the client. What are all the parameter? Version, random, session ID. For each and every session there is an ID. Cipher suite, which encryption algorithm we're going to use it here, and which compression algorithm we're going to use it here. Same parameters with respect to server hello. Then which certificate we're going to use? X.509 certificate. Server key exchange, it's going to give its own public key to the what? Client, so that client it can exchange the data with the server. Then certificate request, it's going to be done by any entities for verification of what? Certificate. Because if either two entities wants to communicate, they need what? Certificate, right? So that certificate is going to be requested by either any two entities. Then server done. After this is what with respect to hello message. If the either client or server, if they want here with respect to server done, so if it want to end up with respect to hello message, then it's going to issue the message. That is what? Server done. Then next thing is what? Certificate verify. Okay, certificate verify, that is purely with respect to, that is certification verification done by any entities through what? Public key authority. So they're going to put the signature. This one is what? Parameter with respect to certificate verify. Then client key exchange, this is the client, it's going to exchange its public key to the server, so that server they can communicate by using the public key. Then finished, after finishing with respect to all the connection, then it's going to generate the hash value. Now both the client and the server, it's going to authenticate by using these messages. And this is what with respect to type 1 byte. Okay, so now length, it is of how many bytes? That is what? 3 bytes. Okay, this indicates what? Length of the messages, whatever the length of the messages with respect to first field, that is what? Type 1 byte. Okay, now it will be we're going to see this one here. That is what? Length it's going to be is what? This is what? Length of the messages. Then content is greater than or equal to what? 0 bytes. With respect to content, what are all the things are there? That is parameters associated with a particular, any parameter associated with a particular message. What are all the parameters are going to be associated with this particular message? That is this one. So these are all the parameters associated with particular message type. First one is message type. What message type it indicates? It's going to take one byte of the memory, so it will take one of the message out of one type of the message out of 10 messages. Then length is what? Length of the particular messages. Then next one is what? Parameter, that is what? Content greater than or equal to 0 bytes. So this is what? Parameters associated with this particular messages. This is what with respect to handshake protocol. Then what are all the how server, client and the server, it going to use the handshake protocol in with respect to phase 1. First, client and the server, it going to exchange the what? Hello messages before what? Connection establishment. First, what are all the parameters here with respect to phase 1? First, it's going to establish the security capabilities. What are all the things are there? Protocol version, and that is what? Version of the protocol. SSL v3 version is 3. Session ID, for each and every session there is an ID. Then cipher suite, which encryption algorithm used here? Either RSA, AES, DES algorithm. Then compression method, which compression algorithm used? And initial random numbers, that is nonce values. So these are all the what parameters are there with respect to phase 1. So these are all the parameter with respect to client hello message and the server hello message. Suppose if server wish to communicate with communicate with the client, then server is going to respond with the server hello message. Then what server will do? Server is going to send the certificate, because server now it this what are all the this one gray color marked here, this is what? Optional fields. Okay, now certificate is going to, because server now as the server received what certificate from the public key authority, that certificate is signed by the public key authority, that certificate is going to be issued to the client. Okay, because now by seeing this certificate, what client can think this is the authorized server, because signature is there, signature is from what public key authority. Then what server will do, server is going to send another message, that is server key exchange. Now what server will do, server it will give public key to the client. Server what it will give, it will give the public key to the client. So by using public key, client it can send the data to the server, right? So why we need public key here? By using the public key, client it can send the data to the server. Okay, first what are all the things? One is what it going to issue certificate to the client, and that is what server certificate. Then server key exchange, certificate request, this is the, now server is asking the client to for what, that is service certificate request from the client, because now server is sending the certificate to the client. In next phase, client is going to send the certificate to the server. That's why it is asking the certificate request from the client, because now server what he can think, okay, if certificate received by the client, then he can think this, that is what authorized client, right? Then server hello done, this is what end of the hello messages. Okay, server, if server is sending the hello done, these are all the parameters are there up to here. These are the messages with respect to client. This is how handshake protocol, that is with respect to phase 1 and phase 2. With respect to phase 1, first it's going to establish the security capabilities, indicating what protocol version, that is SSL v3 version is 3, session id, cipher suite, compression method, and initial random numbers. That is first client is going to send the message client hello. For that server is going to send the message server hello. Then what server will do, now server is having the certificate given by the public key authority. Okay, now that certificate is going to be issued to the client, and also it's going to issue public key to the client. And also now server is requesting the client to give the certificate, that's why it is sending the message certificate request. Now finally what server will do, server it will send the hello done message that clearly indicate that is ending of the what hello messages. Now what client is going to give response, that we will see in phase 3. Now for that requested certificate by the server, now client is going to issue the certificate. Okay, this is the certificate given by the third party to the client. That certificate is issued to the server. Okay, by seeing that server, what server can think, okay, this is the certificate belong to this client only. Now client is authorized one, right? Okay, so that's why client is going to send the certificate to the server based on the server request. Next, client now it's going to send the public key to the server, that is with respect to client key exchange. Then second one is what, now previous whatever the certificate sent by the server, that certificate is going to be verified by the client. That request, that result is going to be sent to the server. That is what with respect to certificate verification. Okay, this up to phase 1, phase 2, phase 3. Phase 3, this is what with respect to handshake protocol concept. Okay, handshake protocol action going to be take place between phase 1, in phase 1, phase 2, and phase 3. What with respect to phase 4, that is with respect to change cipher spec. Change cipher spec protocol, that is what we discussed earlier, that is here SSL protocol stack, SSL change cipher spec protocol. If you want to move the from any pending state to current state, I will tell you what is pending state and what is current state. First, see here, whatever for the encrypted data, SSL record header is appended. For the encrypted data, SSL record header is appended. This SSL record header is going to be processed by the higher layer protocol. Before processing of the what higher layer protocol, what it will do, this for this encrypted data, now it will go to the what pending state. Okay, after this one, appending the SSL record header to this encrypted data, it will go to the pending state. Why this pending state means, because first client and the server is going to be authenticate each other, then only that encrypted data is going to pass to the server. Okay, before sending the encrypted data to the server or server to the client, first client and the server, they need to authenticate each other. That's why they're going to use what? Handshake protocol. Okay, this handshake protocol, what it will do, it will verify the what a client and the server by using the what authorized certificates. By using the certificate, by using certain number of parameters, client and the server is validated, they authorize each other. Then whatever the pending state is there earlier, okay, now you need to bring back pending state to the current state. Okay, that's going to be taken care by change cipher spec protocol. With respect to change cipher spec protocol, it consists of only one field, that is of 1 byte of the memory. Okay, whatever the pending state it went earlier, from pending state bring back pending state to the current state, you're going to use change cipher spec protocol. Okay, now what client is going to bring back pending state to the cipher current state by using what? Change cipher spec protocol. Finally it going to transfer the what hash value to here. Now what server will do, server also it going to change the state from pending state to the current state. Now finished is what? That is with respect to hash value. Why hash value again you are using means, because you need to check whatever the received hash value and the computed hash value, if both are same. Whatever the received hash value and the computed hash value both are same, suppose if both are same, then they can communicate, so both are authorized one. So this is the advantage of hash value. For hash value generation you can use what? MD5 or SHA algorithm. For encryption algorithm you can use RSA, DS, any algorithm you can use. And also with respect to key exchange and also key exchange, and that is given in brief in what textbook, you can check with respect to that textbook. So these are all what? 4 phases with respect to handshake protocol. Then allied protocol, that is allied protocol, that is one of the what protocol stack what we seen in previous class, that is here. Next one is what? Alert protocol, SSL alert protocol. It's going to give the alert messages to the client or to the server, right? For giving the alert messages, you're going to use the alert protocol. So alert protocol, it is used to convey SSL related alert. Okay, that is what? Secure socket layer related alerts to the peer entity. So to both the entities, it's going to give the messages by using what? Alert protocol. Each message, each and every message in this protocol consists of 2 bytes. 1 byte it is with respect to level and 1 byte with respect to alert. This alert, it consists of the alert messages, and first one it is what? Level. Which level of the alert messages? First one is what? First level, that is what? Warning. Okay, warning it was in with respect to warning. Okay, only it will give the warning messages to the entities, but here connection it won't terminate with respect to warning, only it will give warning to the entities with respect to connection. But and another type with respect to level, that is what? Fatal error. Okay, with respect to fatal error, connection it going to be terminate automatically whenever if you receive the fatal error. Okay, so fatal error connection is going to be terminate automatically with respect to fatal error. With respect to warning, connection it won't terminate, only either of the two entities is going to receive the message. That is what? Warning messages. And what are all the alert messages are there here? We're going to see here. First one is what? Fatal alerts. First message, that is what? Fatal means what? Connection is going to be terminated automatically. That is what? Unexpected message. Okay, here unexpected message is what? Whenever if you going to, if any of the entity it going to receive the inappropriate messages, then you're going to see the alert, that is what? Unexpected message. Then another one is what? Bad record MAC. Okay, bad record MAC, that is what? Whenever the two entities fail to generate the MAC. Okay, that is what? Message authentication code. When any of the entities fail to generate the MAC, at that time they're going to issue the alert message, that is what? Bad record MAC. At that time also connection is terminated. Then decompression failure, this is going to be taken place at the receiver side. Whatever the compression done at the sender, okay, now decompression we need to do at the what? Receiver side. If we going to use the here decompression algorithm, if decompression algorithm it going to takes the inappropriate input, if improper input is going to be received by the decompression algorithm, at that time decompression failure happens at the receiver side. And another one is what? Handshake failure. Here, that is what either client or the server, if any authentication failure happens, at the time handshake failure happens here. Lastly, that is with respect to illegal parameter. Okay, illegal parameter, that is what parameters what we see with respect to handshake messages, if it is not proper, okay, if that parameters are not proper, then also connection is going to be terminated between the two entities. These are the fatal alerts with respect to alert protocol. One is what? Alert messages, that is what first one is what? Unexpected message, that is what whenever the entities is going to receive the inappropriate message, at that time we're going to see this one is what? Unexpected message. Second one is what? Bad record map. Whenever two entities fail to generate the message authentication code, we're going to use the this one alert protocol is going to send the message, that is what? Bad record map. At the time connection is going to be terminated. Then decompression algorithm, whatever the compression take place for the sender, with respect to that compression, okay, now we're going to apply at the decompression algorithm at the receiver side. This decompression algorithm, if it takes the improper input, at the time decompression failure happens. Then handshake failure, that is what? Failure to authenticate the two entities, at the time handshake failure happens. Last one is what? Illegal parameter. This is the parameters associated with what? Handshake messages, what we learned in previous, that is what are all the parameters associated with the SSL handshake protocol, that is with respect to this message type. At that time this connection is going to be terminated automatically. Last one is what? Remaining alert. Remaining alert messages are what? That is, this is what primarily, that is what? Fatal alert. Okay, and this is what? Remaining alert. If these are all the another based on some set of the parameters. One is what? Closed notify. Okay, closed notify means what? Either sender or receiver it going to notify not to send any upcoming messages. Okay, so close or notify it going to issue to the this message, this alert it going to issue to the either server or what? Sender or what? Receiver. It going to notify to the sender or receiver not to send any upcoming messages. Next one is what? No certificate. Okay, suppose if any missing certificate is there in the message, if there is no certificate in the message, at that time it's going to send the alert message, that is what? No certificate. Then bad certificate. Okay, bad certificate is what? Whatever the received certificate, if that certificate is corrupted, at that time it's going to issue the message, alert message, that is what? Bad certificate. Then connection is going to be terminated. Next one is what? Unsupported certificate. Unsupported certificate is what? Suppose that this is what? Unsupported certificate, the type of the received certificate is not supported. Whatever the received certificate received by the receiver, if that certificate is not supported that is not in the supported format, at that time unsupported certificate alert messages will come. Okay, so whatever the receiver, suppose that receiver is not received the certificate which is in the not in supported format, at that time it's going to send alert protocol, it's going to send the message, that is what? Unsupported certificate. Then next one is what? Certificate revoked. Okay, so for each and every certificate there is an expiration period. Before that only we need to revoke the certificate. If it is not done, it's going to send the message, that is what? Certificate revoked. Next one is what? Certificate expired. Suppose if the certificate is expired, if it is not revoked earlier, it's going to send the message, certificate expired. Then certificate unknown. Certificate unknown is what? Some unspecified issue it may be arise with respect to what? Whenever processing the certificate, whenever either of the two entities they are processing the certificate, at that time if any unspecified issue arises, at that time this what message is going to be issued to the either client or to the server. Okay, these are all the remaining alert messages, but this is what? Fatal alert. This is what primarily. So this is with respect to alert protocol. This completes what? SSL secure socket layer. Okay, so in next class we're going to discuss with respect to transport level security.